Today, I'm Faith Westorp. I'm on the community programs team here at Elastic, and today we're having a presentation from Ray Myers and Eric Bjerstedt on evolving with Elastic. So Ray is the lead DevOps engineer at Morningstar, and Eric is the vice president of product marketing at GetSet. So we're really excited to have them and excited to hear their talk today. If you guys have any questions throughout, please drop them in the chat or in the QA. And if you're interested in presenting at a future virtual Chicago meetup, we'd love to have you. Just reach out to me. I'll drop my contact info in the chat as well. So thanks, Ray. Thanks, Eric. And excited to hear from y'all today.
Thanks.
Thank you, Faith.
All right, well, let's get started. You want to kick us off, Ray?
Sure. So we're going to, so I'm Ray Myers. I'm currently lead DevOps / site reliability engineer at Morningstar. We're hiring. And I'm former chief engineer at GetSet Learning, which is a startup where I worked with Eric, who is VP of product there. So we're going to give from our respective perspectives kind of the history of that startup's adoption of Elasticsearch as the product evolved, and hopefully this will be useful. And I won't go into a whole lot of depth on the implementation of any individual feature, though at the end we'll have questions if there's anything you want us to go into more depth. This is more of a survey and lessons learned. So, Eric, you want to go ahead?
Yeah, sounds good. And I thought we would start with a little bit of background. So I'll introduce myself as well. I'm Eric Bjerstedt. Currently still the head of product and co-founder of GetSet. We also are hiring, so feel free to reach out. And just to kind of set some context, so GetSet is a private social network for colleges and universities. Our primary users are students, so they use us to meet classmates, share tips, and get questions answered. It's all designed to help make students be more successful, and that is why colleges are our customers. So we provide them with features, analytics, course discussion tools, things like that. But ultimately, they buy our product because it makes sure their students stick around longer and ultimately are more likely to graduate. So we're a Chicago ed tech startup. We've been around for a few years, out in market with a product for a few years now. So we're going to be talking about evolution of Elasticsearch as we've developed our product, and we're going to go way back to some somewhat embarrassing screenshots and pieces of history. So yeah, we'll start kind of from the beginning. And really what we want to talk about in a lot of these examples is how Elasticsearch was a tool for collaboration between Ray as the engineering team lead and myself as the head of product. And it let us step into each other's roles a lot better and better understand, what are the actual things that we can do, and more importantly, like that we can do pretty easily using Elasticsearch. And then also on Ray's side, having a better understanding of the business needs, Elasticsearch enabled him to actually bring a lot of solutions and product ideas forward. So that's kind of the theme running through this that we wanted to touch on. But we'll go back to the very beginning of GetSet. Anything else you want to mention on that before I dive into the first vignette here?
I think that's great.
Cool. So this was one of the first screens we ever built for GetSet. GetSet started out in a very truly lean way. So we had a vision, but we started very small, and Elastic was what helped us grow to that vision. So our goal at the beginning was just to help improve student retention and graduation rates, as I mentioned. And we wanted to start super simple with an MVP that was just based on these little exercises that have been proven to work, or kind of in emerging academic research. We saw what people were doing to help especially like adult learners and underserved or first generation students succeed in school. And they're having a lot of success. And we saw what they were doing, and we thought, well, it's basically built around students seeing stories from upperclassmen, and then that'll help them feel more comfortable and like they can succeed in school. And we thought, hey, that sounds kind of like a social network. So our vision was to take these proven techniques and build them into a product. And we started out super small, just a linear sequence of these student stories. Like if you were a new student starting at a college, you go through this orientation on GetSet, just straight through, 10, 15 screens of these stories. Super simple. So not a social network, but that's where we started, and we gained traction and it was working. Students actually were sticking around longer. So we then started to iterate and build on that. So that's when we started to think about how do we go from this little orientation module into a true community where students are sharing and writing these posts and stories. And that's where Elasticsearch came in.
Yeah, so to give some context on the technical state of the ecosystem as it existed at that point, it was a Ruby on Rails app using Mongo as the source of truth. It's since moved away from that, but that's what was in place at the time, and an AngularJS front end. And so we could we needed to be able to have people search the content, just a standard text search. I'd introduced Elasticsearch before for internal apps, vehicle history search engine, and the first centralized code search the developers had there. So I was familiar with it. I hadn't used it for a user-facing, an end-user-facing solution before, and also it's not in this situation necessarily the simplest thing that could possibly work as you define it, very, very strictly in agile and so forth. If we wanted to use our existing data source to just implement a very, naive text search, we could have done that. But from the past experience, I knew that search is actually a surprisingly subtle problem to get right. And this was something that was going to prepare us for future needs. And it wasn't very long before we ran into one of those cases, which we can talk about next.
Yeah, so we just started with a very simple text search implementation on our mostly text content. We wanted to get something out quickly. We didn't worry too much about bells and whistles. And then we quickly ran into a problem that was solved by stemming, which was a feature, that Elasticsearch offered us, and it solved a problem for us. And more importantly, it was an inflection point for collaboration. So you can see an example of what stemming means there. This is kind of a simple, it's a solved problem, but to me, this was the first point at which I, as a product person, really got to know what kind of tool Elasticsearch is, and even what we mean when we say search. It's more than just punching some text in and finding things that match it. It's more like processing and understanding language. So that was a really helpful kind of entry point in understanding what Elasticsearch really does. I was a linguistics nerd, a linguistics major, in a past life. So this really helped me see the kind of tool it was. And I think from here, I was able to look at what Elasticsearch did from a, what is this bringing to the business, in kind of the same way a developer would look at it in terms of what problems can this solve for me.
Yeah, absolutely. And search turns out to be a very different problem than database querying, and the same tools don't necessarily work well for each. And as a very foundational example, the terms frequency and verse document frequency, TF-IDF, right? Like, I think if you're an engineer that works on a product that uses search, like, you should talk to your product owner about TF-IDF. Like, they should understand this notion that a match on a term that is much rarer in the corpus is more relevant, how that sort of thing is defined. And that's definitely, something that we're able to collaborate better once we understood the dynamics of these tools mutually.
All right, so we wanted to now get into where we actually really started to benefit from some features of Elasticsearch. And that's what we're calling Act 2, the recommending. So we started doing recommendations. So the first feature we used recommendation, type things for was actually failure, and it was called recommended tags. So, we introduced tags as sort of a natural way to help users categorize and to let users start to make sense of the content they were sharing. pretty straightforward stuff. And of course, like, normal, like a reasonable product manager, I was like, no, we can't just let them add hashtags. We need to help guide our users in what types of tags they should use. And so, I saw this potential problem here, and, brought that to Ray, and he came back with some ways that we could recommend tags based on other content.
Right. So given that we had a library of tag posts already, some of which we had bootstrapped in since they had been made before we had added tags, but by using search terms, we retroactively tagged some of them. Now we're able to use the more like this feature in Elasticsearch to say, like, what are you typing now? Okay, well, what posts in the library are similar in content to that? And actually use that in combination with a terms aggregation that show of those posts what tags are prevalent in them, and get a relatively sophisticated recommendation of, like, here are the tags that are most likely to apply to the content that you're using. So this is an example of, like, very often Elasticsearch their features can be composed so that once you know the pieces on the board, you can create fairly elaborate functionality by using them in combination. And if we had to implement, a recommended tags feature like this totally from scratch, it would have been a huge undertaking. Not something we were just able to quickly experiment with, which we could do.
Yeah, and I think so. As I hinted at, this was not exactly a successful feature, but it wasn't because of Elasticsearch. It was actually because the way what this feature was doing was bringing convergence into our kind of taxonomy at a time when we actually needed divergence, right? Like, it was still a pretty young, pretty early stage situation. So it ended up not being the right feature for where we were at. But the experience we had using the more like this function and just thinking through recommendation problems was, again, one of those inflection points for collaboration. And it was really great timing too. So at the time, we were actually had in the works for a few months a sort of major update to the site, where we really took it from just kind of this search engine and a way to share content into it, to a real network where you've got your profile, you've got a feed, you've got ways to connect and follow other students. This was still pretty early on, in the company. This was maybe a little over a year in. And this was the real community. This is when we really launched the community. And so we've been working on this for quite some time. And we had just in the midstream of that had this experience working with recommendation features in Elasticsearch. And so as we were working on this new redesign and overhaul, I asked Ray, like, it seems like maybe we could do some pretty low, some pretty good recommendations for students to help with content discovery. If we, like, at a pretty low cost, if we think through it with Elasticsearch. And so that is what we did. And we ended up, building this recommended feed that was based on a user's likes, as we just kind of shoehorned it into that big overhaul really quickly, and it became really successful.
Yeah, so now, in addition to having a search bar and a results page that's driven by search, we're actually modeling the user's recommended feed, which is now the user's home feed, as a search. And a variety of factors with different weights determine what they see earlier, and that uses function scoring in Elasticsearch. In addition to simple term matching, like traits the users have in common, like this user has the same major as you and other things, we could recommend based on what they've previously liked, using that more like this feature I mentioned earlier. You liked all these posts, those posts have this content, get me more posts that that have similar content to that. And then, that's just one component in the scoring. We also factor in recency, like how new is this content, using Gaussian decay. So yesterday's scores are significantly above those from 30 days ago. But the difference between being 30 days old and 60 days old is actually much less significant. So it does what you'd intuitively expect. And that's another previously solved problem that Elasticsearch had nailed down, and it was easy to do the right way.
Now we're going to switch to the kind of other direction. So in our Act 3, where the theme is, this is not as hard as you think. And when the past couple of examples we've talked about were ways that, I was able to recognize certain business problems as opportunities to deploy Elasticsearch to get a lot of value really quickly. This is sort of the other way around, where Ray is seeing these business problems and saying, hey, I've got some stuff here that could solve those problems pretty quickly. So the first of these is what we call at GetSet Influence. So Influence is actually a product that we offer, and here's how we built it. So we had a little more than a year in market now with our community platform, and we had one of those classic startup moments where you've got the bones of your vision in place, you've got like a product market fit going on, you've got paying customers, and then your CEO really wants to take it big. So our classic startup moment, our CEO walks into our bullpen one day and he's like, guys, I've got this crazy idea. We've got all this great content. A lot of it is essentially testimonials for all these resources that schools offer, like their tutoring center or advising or financial aid. That are real experiences students have had, and schools, it's like pulling teeth to get their students to use these resources. So what if we gave schools the ability to send out those testimonials to all of their students? And what if we personalized all of them so they were coming from a student you were most likely to identify with? So kind of a complicated idea. I mean, there's a lot going on there. And so Curran brings this into the bullpen. Curran is our CEO. And he's like, Ray, can we do this? And Ray's essentially like, yeah, give me 2 weeks, which is kind of a ridiculous answer.
Yeah, so it's turned out to be a relatively simple batch system. You provide a list of users, or they might be prospects that haven't been in the system yet, and you provide the posts that you want to consider for this intervention. And it just loops over each user, and for each one, it picks the most recommended posts of your pool and sends it to them in an email. Now, we already had email notification functionality in a service we could call. We already had the recommendation mechanics from building the home feed implemented with Elasticsearch. So when you put it together, we just did the weighting a little differently, and this boils down to a few hundred lines of glue.
Yeah, I mean, I think because there were a lot of things that Rails we'd already put in place that we could run on, this was actually relatively easy for us to spin up. We'll talk about some of those kind of behind the scenes things we did that really made some of this possible. But it's interesting how, if you think about what Elasticsearch can do in terms of recommendations, those are things that give you a moderate level of sophistication very quickly. And for most businesses that where recommendation isn't their core business, that's huge. I mean, this is like a new product that our CEO was then able to bring to market. He sold it to our current customers to test it out. We tested it. It was extremely effective. We generated like a 2x engagement with those school resources over the emails the schools were currently sending. So our customers loved it. And it tells a good story. It tells the story of, okay, you guys are a community, but what else can you do for me? And one of the things we can do is help you get the most out of all that really great content that your students are sharing. And this is an instance where Ray was like, okay, this sounds like a problem that Elasticsearch can solve, and it turns out to be to become a product that we haven't touched a lot since that initial implementation, and it's delivered messages in the millions at this point, and has generated 6 figures and counting revenue. So yeah, I mean, it's huge return on investment for the company. And we've done a lot of analytics as well. So this is another instance where, we've got our core product out, it's delivering value for clients or the schools that we work with. And we want to figure out what are the other things we can do with for these customers that are really unique and can bring value to them in a way that no other vendor is bringing. And really, again, the value is in the content, right? How can we help them make sense of what their students are talking about in the community when you're getting these thousands or tens of thousands of posts in a given semester or course or whatever it might be? There's a lot there. So how do you make sense of all of that? And this was an instance where Ray just saw this problem in the business. We were trying to give metrics like you see the numbers at the top of the screen. How can we help see how much is going on? And Ray saw this opportunity to use Elasticsearch to really make sense of a really complicated problem.
Yeah, so trying to extract some kind of meaningful value from the data and at the high level. And by this point, I was getting pretty familiar with the annals of the Elasticsearch manual, and there had been something I'd wanted to try called the significant terms aggregation, which tells you which parts of your data are, they call it uncommonly common. So what's showing up more often in this slice of data than shows up in this background set, maybe all of the rest or some other background set. And that's really useful because if you're just looking for the most common words in your data, you're just going to end up seeing the most common words in the English language. It's going to be really unuseful. You can take out stop words, but you're still just going to see a bunch of really common stuff in general and nothing that's very particular to what you're looking at. But with significant terms aggregation, you're able to see, well, what's peculiar about this chunk of the data, and really by giving our customers the ability to then move what chunk they were looking at, see a lot of really interesting stuff that they could then drill down into. And so we do that first with tags, and then the later introduced, I think when we were doing this page, they had just come out with the significant text aggregation, which lets you do that not just with a keyword term, but with freeform text in a relatively intelligent way to show what words are showing up the most. And that's been something that people can play with, then look at, okay, now what's click on the word enrollment. Well, what are people, what's common about the posts that have that word in it, for instance. And there's a whole second page where they can view stuff about that.
Yeah, so and this is another example of, Ray brought this forward, and then we were talking about this concept of your background set and how you can kind of move the window you're looking at. And I was able to very quickly connect that to, okay, we know that if I know anything about a college, it's that they love to segment down their student population into transfer students, international students by major, all these, that activity in and of itself seems very satisfying to a higher ed administrator. So, that would very quickly, I was like, oh, we should give them the controls to filter that set to one of those groups. So if you want to see what are my students who are in the military talking about, you can do that. And that immediately clicked a switch in our customers' heads, because it ties this thing that they don't really know how to work with, because it's not part of traditional education, which is a social network. I mean, it's kind of ironic because campuses are a social network, but when you think about it in a digital and in a data sense, this was the kind of thing they're looking for. I've got all this stuff, but I don't know how to make sense of it. Can you give me something to do that? And then couple that with the ways that they're already thinking about their different student subgroups, and it just really works for them. And this isn't I want to pitch you my product. The idea here is that Elasticsearch really enabled us through the way Ray and I were collaborating to get to that. If it wasn't for Elasticsearch, I don't know what tool we would have used, probably something else, but it's not about the capabilities it had, it's about the way that it gave us this shared language or this shared space to collaborate in. And when in a world where like a product person or designer often doesn't with an engineer. You know, it's hard to find places where there's really strong overlap where everyone is really speaking the same language, and Elasticsearch is one of those things for us. So to kind of wrap up, we wanted to talk about some of the stuff that really set us up to be able to even do these things. You know, it's not like we just stood up like an Elasticsearch cluster and then all of a sudden we were able to use it in all these different ways. There's some smart things we did along the way that we thought might be helpful to talk about.
Yeah. So on the back end, if you're using Elasticsearch with a lot of different features in your product, as opposed to just like one page, I started to notice that the way that just the building of the queries and managing the output, and Finiscroll, things like that, a lot was being repeated across different places in the app, and eventually I got tired of that and built, like, both on the server side in Rails and in client side JavaScript, search libraries that were GetSet specific that would wrap the Elastic interaction. And that once we had implemented that, things got a lot easier because there was a lot of different ways that we might build a query, but there were a lot of commonalities between them and a lot of expectation that they behave consistently. And so once there was just a known, okay, this has been vetted, this can be used anywhere in the code base to, return the right search results for this kind of situation, that made things a lot easier. And in particular, in the visibility logic, like there's complicated rules to what students are supposed to see, what other students' content. And having that built into a centralized search framework allowed us to make sure that, okay, as long as you're calling this, the visibility logic is being respected, you're safe. That was definitely a case of recognizing technical debt, and we prevented a lot of trouble by getting that relatively early. Then we had there's a whole service we call Sync that runs in the background and communicates new changes from the source of truth, which is now in Postgres, for posts and comments and other content in the system, to then post that into Elasticsearch and make sure that that's kept up to date relatively soon. That is, that comes with a cost. Like, maintaining a search index is expensive. You're going to have to build some amount of, expensive in what you've got to build, what you've got to spend time on doing in order to make sure things stay healthy, keep the data flowing in there the way you expect. And so that was certainly some expensive time. It was definitely a very good investment, but I probably would have invested more in it earlier, even because it's definitely a process that's like subject to the volume of your data as it increases, and it can become a pain point if you don't stay ahead of it. It getting backed up with changes and so forth if you don't continually optimize it. Once we put in auto scaling for it, that cleared up considerably, and some other handling. We also we didn't start out on Elastic Cloud, but we moved to it. We initially I was just managing servers on EC2 directly, automated with Ansible, and I found pretty quickly that in a company of just under 10 people, that I did not want to be spending that amount of time managing servers for any of the data stores. And I found that the Elastic Cloud offering was like really plug and play and has been very low maintenance over time. Let's see. So I guess my main takeaway here is choose your tools really well. Like, whatever you put in is gonna cost you to keep up, but this was definitely a case where it was a very well chosen tool. And learn your tools really well once you've invested in this, and then try to understand the business trade-offs and know how the features of what you've invested in can help find new business value.
I have nothing to add to that. That was well said. So I think that concludes our prepared presentation, but we would love to answer any questions or discuss anything you guys are interested in.
If you could type your question in the chat or in the Q&A, that would be great. Thank you.
Yeah.
I see a question that says, how much does hosted Elasticsearch cost? That's a great question. I'm happy to connect you with a sales rep to discuss that after the call. On the community team, we deal mostly with the open source version of Elastic, but happy to connect you with someone who has an answer. There's a Q&A question that says, did you find you need to complement Kibana with a connector for a click-through?
In our case, we didn't use Kibana a whole lot except for debugging occasionally. So when we provide analytics internally and externally, we're building our own interfaces for that. So I don't think that question really applies to us. On the cost question, I don't know if it'd be appropriate or not to, like, I could tell you what it costs us, but you would it would be totally different. But I found it to be it was comparable to other managed data stores we were using, such as MongoLab and Amazon RDS. At the similar size, it was a pretty similar cost. And when I started using it, it cost less by a little bit than a minimal Elasticsearch cluster provision with raw EC2 nodes. So that was actually like I wasn't paying anything extra for the management. It was just the same.
Oh, sorry. Right. I think that there was another question that said, did you find you need to complement Kibana with a connector for click-through?
Yeah, so we weren't using Kibana in the end user interface. Okay. So that question doesn't really apply to us, unfortunately.
Perfect. Okay, next question. With all this quarantine time, what other projects, if any, are you working on these days?
So actually, I'll answer with something we're doing at GetSet. So Ray is no longer at GetSet, so I'll give you kind of something he might not know about, which is we're now actually, coincidentally, using Elasticsearch in a new way to help our students during this time. So students are going through a lot of disruption where campuses are closing. So they're either being sent home or they're having to lots of disruption around the way school typically works. And our tool is really well suited for that. So it gives you a place where you can come as a student, stay connected to your student communities. And one of the things that we're working on right now with Elasticsearch is a way for you to get connected with another student to do wellness check-ins. So just a person for you to have kind of human contact with that you might not otherwise meet during this time, so you can maintain human connection with other students. So the idea is that we're using Elasticsearch to make those recommendations. Yeah, we're actually very busy at GetSet during this time because we are serving customers where they now see a much bigger opportunity for what they can do with us.
Mm-hmm. And Morningstar is also, firing on all cylinders remotely. That's one of the advantages of being in technology, I guess, is oftentimes you can work remotely. But I am always looking at internal apps that I can kind of cook up and show around and see if they stick. That's kind of a work hobby of mine. And in my spare time, at the moment, I'm mixing down a friend's album.
That's awesome. Next question, is there an easy to use admin tool with Elk Stack so the business can tune the product or turn the engine?
I guess it depends what you mean by the business. There is a very good web admin interface to your Elastic cluster on Elastic Cloud. That's like one of the big attractors of it. I haven't seen anything better in other hosted Elasticsearch offerings. So the business. So that means GetSet in general can tune their Elasticsearch cluster settings easily. They absolutely can. If you mean the business, as in Eric and the powers that be that we answered to,
Yeah,
they shouldn't.
That's what they meant. They clarified business means someone who's not technical.
I consider it to be a technical operation, to be an admin operation. It's. I think Eric would be able to be relatively easily trained to be able to use it. So I'd say it's semi-technical. It's certainly not the level of technicality of managing a server yourself. But I consider it administrative action.
So I can speak to the fact that, so Ray, we actually are starting to implement Kibana and to use it for APM, like as we speak. So we don't have it up and running fully yet. We don't have our data flowing into it. But the intention is that the business, i.e. me or a couple of other people who are non-developers, can go there for information. So the idea is that like the non-technical folks will be using it for decision making, or to kind of know, okay, where are we at with how we're how the cluster is performing, and what thing, like, are there potential problems? So we might know, okay, we need to dedicate some time to this, or if there's going to be increased costs coming up in the future, things like that. But I'm not anticipating that I'll be using it to actually make changes to the implementation. That's something I would bring to one of my colleagues and work through.
Yeah, and there is a slider in there that if you in a pinch, if you needed to, for example, it depends what you mean that they'd want to do, but like if you needed to increase the number of nodes in a cluster or something in an emergency, or increase the memory.
I did that actually one time.
Yeah, so there you go. A business user has done that in a pinch, but is few and far between the situation where you would really want your business users to be in there horsing around, I guess.
Yeah, that was a situation where, we're still a small company, so it was like a Sunday morning or something, and I happened to see the alert that our cluster was like, above its threshold on memory for a little too long. So I knew our developer was not available, the like main guy who owns that. So I just popped in and increased the size on the node, and I let him know, and he's like, yep, that's what I would have done too.
Awesome. We have one more question in the chat. Can you guys explain the unified search framework again?
Great. And this would have been a good thing for me to make a code example. There's a whole lot of code, but maybe I could have found like a simplified area of it. But the big part of it is there's the official Elasticsearch client libraries for every major programming language. In our case, Ruby. And that lets you build a big hash of the search query you want to run and send it off to Elasticsearch. And when you get started, you're everywhere that you might want to use Elasticsearch in your app might just directly call that client library. And what we found, though, was that led to a lot of duplication because the queries we were building were actually pretty big. Like, all this function score and, significant terms and more like this, all these various ways we were using the features in combination with our business domain create a lot of duplication in the code base. And that's like more work than it needs to be. And that's risk of it deviating in one place or another as you make an update in one place. So it's just a matter of like extracting into our own private library, just used within GetSet, a library that creates queries for Elasticsearch and interprets the results, and facilitates us, moving in between our business domain and Elasticsearch syntax and back. I hope that helps.
Awesome.
Yeah, another benefit of doing that was that when we have several different applications. There's student facing, there's like internal applications, there's the like school admin and school faculty facing, and the unified framework, when we implemented it, one of the key things was that it enabled us to, if we had a feature in one of the applications, and then we realized, hey, this actually could be super useful over here, it was very easy to add it to another place in our platform, because the search was all centralized. So anything that one app was doing or using, another app could use like instantaneously almost.
Yeah. Like before that, it would be like, okay, now this app needs to do name sorting or whatever it would be. Oh, I thought only this app was going to need to use names. And after we had done that, every feature that we had implemented anywhere through search was available anywhere. And there was also a component of it that was on the client side. So there was an Angular directive that just like displayed search results, and it was used in combination with thing that called the search on the client side. And so you knew that if you were using that directive, it was just gonna get the first 20 results first or whatever, and then when you scroll to the bottom, it was gonna go fetch more. It was gonna handle that behind the scenes. Just write once, use everywhere.
One of the other tools we talked about, we could give a really quick, summary of something I think has worked really well, which is the sync function, the sync app, which keeps the search index up to date. So we use Amazon SQS for that, which is a really good fit, I think. And one of the issues we ran into with it that we solved relatively easily was when the SQS queue would get backed up, because a lot of stuff was happening on the site or in the community. So we ended up moving that onto Fargate, which is an Amazon service that does a bunch of stuff, but it includes like scaling up, the number of boxes or whatever you're throwing at a problem. So it works really well with the sync queue. So as the queue gets more stuff in it and there's more index updates, it adds more workers to just clear out that queue, and then it scales them back down. So that was like that's been a good solution for that part of the infrastructure.
For a product owner, that was surprisingly accurate technical description of what sync does. Very, very good. Nothing to add there. And another thing that we noticed was that it would often back up with updates to the same data. It was just kind of naively done, because updates tend to cluster. Reads tend to cluster, writes tend to cluster in almost any system. And so if the same user is updated a whole bunch of times, we'd have if things got backed up, we'd have several different updates for the same user in the queue. And really, like, there might be 1,000 items waiting in the queue, but only 100 of them are unique things that need to be updated. And the rest are just going to update the same things over again. And given the latency of the queue backing up, they're redundant. You can prove that. So we implemented some deduping in there, which helped a lot as well. I think we might have hit the end of the questions.
Yep, that's all that we have for today. So unless there are any last minute questions, thank you guys both for the presentation, for your time, for answering all these questions. It's great to have you on. We hope to have you back at a live event maybe one day in Chicago.
Absolutely.
And everyone else still on the call, if you'd like to present in the future, please just let me know, and we'll be happy to have you as well.